Okay.
Right. So, welcome to this Open Security Summit session in June 2024. And we actually have Stefan going to talk about which a subject which really actually at the moment really dear to a lot of the stuff I'm doing, which is the AI, Gen AI, and how to make us more productive. To be honest, I really already like the title because it's not about replacing security engineers. It's about really empowering them, right? Like the next generation of these security engineers, right? For me, the thing that I found very exciting now is that there's a lot of problems that we always had in cybersecurity that I think we can now solve, right? And
Absolutely.
looking forward to your session, and we'll have a chat in the end with more topics. But over to you.
Looking forward to it. Thanks for having me. And yeah, really happy to be here. So today we're going to talk about the rise of AI security engineers. And there's going to be a few things that we're going to cover. Of course, I'm going to start with outlining the problem space before to really drive the point home of where are we today with the current tooling that exists and how we actually, what the problems are with that. Then I'm going to talk about the 6 levels of application security automation with a bunch of examples. I'm also going to show a demo. And then I'm going to just wrap it up with a bit of an outlook of where I think this is all going. And yeah, it should be fun. So to begin, so for those that don't know me yet, I've actually been in security for quite a long time. Started in uni in 2003. I did my first exploits publishing back in 2005. It was fun for back then, Milworm and these kind of platforms were around. I became a security consultant in 2006. And I think this was a really interesting time to become a security consultant because back then there were no tools out there. You have to do everything yourself. You have to really think about how you can automate things, how you can actually start thinking about writing the first tools, etc. And I was fortunate enough to do a bunch of things there as well. Not just pen testing, but really going deep into source code reviews and a bunch of other things. I also got really into DevSecOps around 2015. And I was fortunate enough to work with a lot of different companies to actually not just do the consulting, but help them get the capabilities in terms of how you can automate these processes, how you can work together with the different teams. And this was a really fun journey because, back then, switching from waterfall to agile and DevOps and making security fit into that was just a really interesting challenge. And I think a lot of this is going to be relevant today as well as we talk about AI. I also switched back in 2016 to becoming a security engineer. And I think it's also important in terms of experience because if you're a consultant, you always give everybody like a bit of a report of how the perfect world looks like. But if you're actually responsible for the security of a big app with millions of users, you essentially have to figure out what works, what doesn't work, and how to make security more practical. And while doing this, I realized that all the tools that were available back then really sucked. And that's why I decided to start Guardrails back in 2017. And the last real big milestone for me was really looking at GPT-4 back in March last year. And honestly, I've been completely obsessed with generative AI ever since. And so to me, my heart is really at the intersection of software, security, and AI. And this is why I'm really excited today to be here and talking about this, because a lot of the stuff that I've been working on in the last year, a lot of it was stealth, a lot of it was not really shared much. But yeah, I'm really looking forward today to sharing a little bit about what I've learned and what I think is going to happen here. So with this in mind, today we are kind of going to answer how to get from manual control but to self-driving, but for security, and what all of this actually has to do with AI security engineers. But before we actually start doing this, what I would like to do is really drive home the points and the problems that currently exist, so that we can actually more have a better context around the solutions that we're going to present and how AI can actually help us with all of this. So first and foremost, if you look at the number of vulnerabilities that are disclosed publicly every year, and this is from the CVE details, we can see that a trend is very clear. More and more vulnerabilities are always reported. So in the last 10 years alone, it went up from, I don't know, around 8,000 all the way to almost 30,000 last year. And as of yesterday, that number is now 18,422 for this year alone. So if we actually take this and think about what this is going to look like at the end of the year, we're probably going to be closer to 36,000 vulnerabilities disclosed every year. And obviously, if this would be our stock portfolio going to the right and up, it would be great. But when we're talking about vulnerabilities being disclosed, it's actually not a good thing. Similarly, if you look at the data breaches, and here I've just looked at a number from the US, of course, the number of breaches has been going up almost consistently in the last 10 years as well, and before that. But in the last year alone, in the US, the breaches have increased by 78% as well. Even though the individuals impacted have gone down, but yeah, the number of data compromises going up is, of course, a very, very worrying number to keep in mind. So the question is, why are these numbers actually trending in the wrong direction? So first question is, we don't have the knowledge, right? I mean, must be a new thing, but obviously we all know that, especially on this call, that this has been public knowledge essentially since the early 2000s. OWASP came up, of course, late 2001. OWASP Top 10 was released in the early 2003s, like in 2003. And there's been countless security books, countless courses, some of them even free. You have, press awareness, all of these things. So clearly, it can't be a reason that people don't know about it. And there's maybe another thing to keep in mind, which is, are developers actually educated when they learn about this in uni or in school? And I think that's still one of the the areas that is a problem, because actually a lot of developers, even those that earning their living with it, they're typically self-trained or to a large degree self-trained, and security is not typically on this curriculum. And yeah, I think that is, of course, an opportunity, but it's definitely not something that nobody knows about security and we don't have the knowledge available to us. So the next point is, okay, there's so many new types of attacks, it's really hard to keep up. And so this is also not something that's actually true, right? Because if you look at also, again, the first documents that came out there, they've been largely the same kind of attack vectors for the last 25 years. Doesn't matter if it's buffer overflows, format strings, or cross-site scripting, SQL injection, all of these vulnerabilities that we still see today. Yes, maybe a few of these have been changed and have been new kind of patterns have emerged, but it's very rare, and it's not something that we actually have to keep up with. Of course, when it's about CVEs or publicly disclosed vulnerabilities, the number is of course going up, but the approach is always the same. We just patch it. The CWEs behind it are actually not changed much. And to further illustrate this, here's another example from the CVE details, where you can see over the last 10 years, all of these categories have been roughly the same, but still we're actually getting more and more vulnerabilities, or the most red number, or the darkest red, is actually where the highest number was reported. So in some areas like buffer overflows, yes, it's going down to a degree, which is great. But yeah, if you look at things like SSRF or file inclusion and all of these things, they're still very much the same, and we still have all of these issues nowadays. So the next question would be, these problems exist because we don't have the right tools, or we don't have the tools. And again, here we do know that the first security tools have been around since pretty much 2003 or even earlier than that. And of course, not just have these tools been introduced back then, But nowadays, if you look at the landscape of security tools that are out there, I mean, for every single thing that exists, there's probably 50 different tools. Don't forget the open source tools and all of these things as well. But so that's clearly also not something that's a problem. Now, okay, so maybe the tools are there, but we don't have the budget to address all of these things. So that may be true in some cases. But to be fair, the prices have gone down and there's much more choice available because of the competition. Plus, if you look at the worldwide security spending, the numbers have also consistently trended up ever since. So also not a real reason for that. So finally, we don't have the people. Actually, that is pretty much true. So if you look at another one from the US, in a period of the last 12 months, that was actually last year, 663,000 jobs were opened, but only around 196,000 workers were actually available to fill these jobs, regardless of whether they were actually qualified or not. So yes, this is actually a problem. And this is, I think, an important one that we also have to understand how we can improve this and how AI can help us with that. So there's actually one more thing, right? So we have discussed that, of course, tooling coming out there, like that we have all of these problems with more and more vulnerabilities being disclosed and more data breaches coming up. And all of the reasons I've just brought up were actually not reasons to justify why these numbers are trending the wrong way. Maybe with the exception of there's not enough people for that problem. But we also have to keep in mind that if we think the problem is bad right now and everything is getting worse right now, the number of developers is growing every year as well, right? So we also know that essentially since the last couple of years, the number of developers that exist out there is growing every year. And this may not be a huge growth number here, but it's still significant and it's still important to understand that that means every year millions of developers that are new developers join the workforce. And there's obviously also maybe in some cases an experience gap and all of these things that we have to consider. Another important part to keep in mind here, now we're starting to talk about AI. If you look at this statistic, which is actually provided by GitHub, back in 2022, around 28% of code were generated by, back then it was an early version of the GPT, like I think it was, I forgot the name of it, but it was essentially a small portion was being generated by AI of all the code generated for a developer. In 2023, this number has already gone up to close to 50%. And in 24, where we are today, that number has already crossed the 60% mark, which means over 60% of code generated by developers that are using GitHub Copilot is generated by AI. And if you now, the projection is for next year, is essentially that number is going to be close to 80%, which means every developer out there that is starting to use more and more of these AI-generated assisting tools is not just going to be more productive, they're also going to produce a tremendous amount more code than what they're able to produce today. And that's going to further, increase the problem that we have with having so much more code being generated. And yeah, so we are here right now. So that number is going up quite a bit and it's going to continue to go up. And another important point to consider here is that AI copilots are just the beginning. So the example from GitHub Copilot, it's actually, it has improved already quite a lot in the last couple of years, but it's still pretty much autocomplete for code. Typically a few lines of code, maybe a function, but it's not necessarily, writing the whole, like a whole project for you from scratch yet. And again, there's already code spaces coming up that is changing this. But yeah, if you look at this graphic here, you see AI copilots is like the small concentric circle, but AI coding assistants are essentially already readily available. And what they do is they essentially allow you already to make multi-file changes in your code base. And so, for example, I personally use something called Cursor and also Aider, and they really allow you to write so much more code, so much more efficiently, but they're not necessarily solving the hard problems for you. They're more like helping you with scaffolding, a lot of other things, and you can really see the productivity gains across the board. And yeah, super interesting stuff as well. And I hope a lot of you listening as well already had a chance to play with these things and applying them to the workflow, whether it's for security engineering or normal engineering or anything else. It's really a big game changer for productivity and also, most importantly, being able to stay in the flow, in the zone, without having to go off to Stack Overflow or Googling to find a solution just to come back to figure out what the problem is. So really important part. And what we're starting to see as well now are actually AI software engineers. Like maybe some of you have heard about Devin. There's also Open Devin, there's Devon, there's Auto Code Rover. There's a bunch of these coming up now. And this is quite interesting because they are now starting to not just autocomplete code for you, but you feed them a ticket, a Jira ticket, and they will go off and actually start understanding the ticket, planning the steps needed to actually solve the problem, and then actually provide a pull request with the changes and the tests and all of these things so they can do it. The bottom line about all of this is only going to get better and better and better. But it's also important to understand that even though now, if anybody wants to become a developer, even without any proper software engineering training, they can start building code at scale and really solve and tackle a lot of problems, but just using the natural language. And I think it's really important to keep this in mind because you have to understand that people that have no idea about security or coding, they have no way to understand if the code that they're producing is actually good or not. They don't only care about these kind of things. Anyways, quick note on that, just to give an idea where we are at already. This is an example of these AI software engineers. And there's like metrics out there that actually show that out of a collection of 2,000 or close to 2,300 issue pull request pairs, you can actually see how many of these could be actually autonomously solved by these AI software engineers. So we are now at around 90% is state of the art. A year from now, this is going to be, I would guess, over 50%, if not more than that. So this is a very rapidly changing space. Now, let's talk about the security part of that. As we know, AI-generated code actually can be insecure. So this is an example that I've actually seen myself when I was working with the solution I had. I was working on an insecure code base called Valpy, and I just asked it to add a function to delete a user. And because in the context that it had also insecure functions. Like in this case, you can see it's a SQL injection. So it says, yeah, sure, no problem. Here's a function that deletes a user from the database. It takes a username as an argument. It deletes the corresponding user from the database. But as you can see, it actually introduces this in an insecure way. And that's not just true for Cursor. That's also true for Copilot. And just knowing how to prompt and all of these things may actually make a difference. But again, if you don't have the training, if you don't know what to look for, you cannot be sure that the code that is generated is automatically secure. Very important to have like a second set of test cases or a second set of eyes, be it AI based or not, to ensure that it's actually being done securely. Otherwise, all of the code being generated, much of it being insecure, is going to cause a big issue. And another point is that AI cannot just be used to generate code. So here is also two examples to further illustrate the problem that, this is not just going to be used to actually write code and build new applications and all of these things. This is also going to be used by bad actors to come up with very much superhuman hacking schemes that may be aimed at military, but they may also be actually aimed at, organizations and all of these things as well. And so this is actually from a very interesting blog that came out just a few days ago called Situational Awareness AI. I strongly recommend everybody take a look at this. It's very, very interesting from an OpenAI employee. And the other one we see here is actually from OpenAI from February this year. They've actually noticed that malicious, like state-affiliated threat actors were starting to use ChatGPT to identify like new ways that they can, create attacks or misinformation attacks or other things. And so this is going to come, right? It's not a question of when, of if, it's a question of when. And just imagine the first time somebody wrote the computer worm, I think it was the Morris worm back in the 1980s or something. It did quite a bit of damage, but imagine you have like a supercharged AI worm that actually can propagate to a lot of different types of applications and essentially automatically pen test a large degree of the internet. This could be a real issue and then self-propagates, etc. So something to keep in mind that is also important to understand for this. So with all of these problems lined out and what actually is happening here, I hope I set the stage well enough to make it very, very clear. The problem has not gotten better up to date. And if anything, it's only going to be multiplied in the future with for all of the reasons that I've mentioned. And I think that's why it's so important to understand how can we actually empower, like how can we put the humans out of the equation as much as possible and allow them to essentially, be able to deal with all of these issues and help organizations really make sure that they are secure, they can build the future, they can work on all of these things without having to worry about being hacked. And so I think this is really where we have to rethink about how security is actually done. So with this in mind, so we all know about the all of the latest advancements in self-driving. For those of you who follow Elon Musk and Tesla, you're well aware that this FSD version 13 and now 14 is coming out soon, is really starting to show so much promise where you can actually really create very safe cars that automatically drive people completely autonomously, no matter what the situation is, in a very human-like fashion. And maybe some of you have even had a chance to try Waymo already, which is the first completely self-driving robot taxi, if you will, that essentially is available, I think, in the States, in San Francisco, and maybe a few other places. But this is actually very interesting, right? Because if you think about it, if you look at the number of traffic accidents and all of these things, the number is also going up. Maybe the amount of fatalities is going down, but even though the human error happens, no matter how secure the cars are, how much better safety precautions they have, how many more airbags and all of these things, because the problems happen also to a large degree when people are actually tired or drunk or whatever other reasons there may be. And I think that's really important because going from manual driving to fully self-driving will save millions of lives over years, right? So this is going to be very, very important. And I think it's also important to think about what this means for security, because if you think about it, we also have the same issue. Like the more we have to do it manually, the more we actually are prone to errors or missing things and not being able to deal with the entire organization portfolio that we have. And to this extent, I'm introducing these 6 levels of application security automation. So we're going to go through them one by one in the next couple of slides. But yeah, in a nutshell, this will show us how to get from level 1, which is no automation, step by step until we get to the final levels of automation, which are akin to fully self-driving. And maybe the term that will come up in the future, instead of just having fully self-driving, you may have FSS, which is fully self-securing. So this is something where I think we should spend as an industry a lot of time and effort figuring out how we can automate more and more of these things and how this actually is going to look like. And also, what are the different milestones that we should set ourselves as an industry to understand where we headed, where we're going here, and what does that mean for us as an industry and for, of course, all the organizations that would benefit from that and the developers and security teams, etc.
Stefan, just a quick
Okay.
one.
Yeah.
On that level 6, shouldn't that
Mhm.
be, go back, shouldn't that be fully automated?
Correct. This should be fully automated. So in this case, I've actually just updated this in terms of um, how we name these levels. Because if we are actually here, it says full automation.
Yeah.
But the thing is that actually on these levels, there is also different levels of maturity. And I think this is where at the very end, I'm going to loop back to saying, what does full autonomy actually mean? Because it means combining all of these levels together at a certain degree of what
Yeah.
this is.
But I
And
think it'd be
so,
good. Yeah, this is by the way, this
Mhm.
is great, right? Because I think it's a great to have this model. I think you should try to copy as much as you can the other levels, even name them, right? Because to be honest, like you want that, right? You ultimately what would be the best one is that a security vulnerability is written and it gets patched automatically, right? Doesn't even get like the automatic patch, right? Of the self-healing. In the past, we talked about it, right? Like self-healing
Mhm.
applications, right? An application that can detect, and I think it's interesting to have that definition of full automated security, right? Which I
Mhm.
think is going to be one of the objectives. So cool. Now this is really good.
Absolutely. And feedback is appreciated. I actually just changed these earlier today. I was using the exact same levels that we had here before, but I thought it would actually encapsulate. It's a little bit more nuanced than that. And I want to add a little bit
Actually,
more detail.
go back to
Hmm.
the levels. See, this is actually, to be honest, I actually like these names because
Yeah.
even the
Mhm.
driver, right? You can argue that the developer assistance, right? So, but the names are quite good actually. No automation, the driver, developer assistance, right? Partial automation, conditional automation, high automation. They actually are nice names.
They are. I honestly like. I'm happy to discuss this as well because I was actually like, okay, what is partial automation versus conditional automation versus high automation versus full? So I thought there's actually it may be a little bit ambiguous, and I thought it would be good to actually change this to something. But I would love to talk about it more because I think this is something that would be really great to talk about and
Yeah.
actually standardize as an industry as well to see, okay, how can we actually make this work? So I'm gonna go through these, and maybe it makes sense anyways how I present it, and then we can discuss at the end as well and
Also
see
take
if
into
there's
account that
anything to improve.
those definitions would evolve, right? Like what we call full automation today is different in 3 years
Hmm.
from now, which is okay, right? And even I'm sure that definition there, what they call today full automation of cars, it will change once you reach that platform. And then you go, actually, we want more, So cool.
Yeah, awesome. All right, so let's start with level one. It's essentially no automation. So as you can see here, this is effectively requiring a human that manually reviews code for vulnerabilities. And honestly, like this was a lot of fun. This is how things used to be done when I got started. You can find a lot of complex vulnerabilities, and you can apply like human reasoning and human level team communication. So if you're in a team where you can actually work alongside developers, it's fantastic, right? Um, but yeah, the problems with these approaches, obviously, it's very difficult to scale across an organization, right? You can do this maybe well for one application, but if you have 100 developers working on that, you will struggle. And of course, if there's 100, like thousands of applications in the organizations, there's just no way. And I think another important part is also results are typically not consistent and repeatable, which means that if you have two people looking at the same code base, you may get completely different results. Some issues would be missed, some would be the same, some would be, it's like very inconsistent. And obviously, it's also very labor intensive and very costly to actually pull off. So this is essentially in the early days how it used to be. Can still be used on top of everything, but it should be used wisely for high risk applications as well. And I think down there you can also see in terms of effort to detect one vulnerability is obviously the highest possible effort because you have to go through everything, you have to figure it out. Triaging effort is a little bit less because the person actually looking at issues will already, of course, have the triaging context. Fixing effort, you of course have to produce the right fix. You have to talk to developers. So it's somewhere in the middle here. But the app risk is probably going to be not too bad because if a person really has the time and the time to go through it, it will be done quite well. So with this in mind, we can start and go straight to the next level, which is on-demand scanning. So this is where a human is now assisted by security tools. And that human may be a developer, it may be a security engineer, or anybody involved in this process. And the benefits are, of course, suddenly when you start using tools, you can cover large code bases in a fraction of the time needed. And it's also, of course, much easier to perform all of these things at scale as part of a well-defined process. So, for example, think back to waterfall back then. Okay, we have a security testing time. This is the release. Now we do the testing. We scan it. We iterate on it. Right. Of course, it's also much more consistent and repeatable because you run the tool against the same code base. You are expecting the same results coming back, and you expect the same results to apply to all the other repositories that you're actually running, regardless of who actually runs the scan. The disadvantages here are there's a delayed feedback loop with developers typically, right? So you actually start the scan sometime when the code is complete, and then you essentially only start looking at the vulnerabilities. You also have to, of course, look at a lot of results that need to be triaged, which typically are done either by the person starting the scan or maybe handed to the developers. The fixing advice for these tools was typically very generic. And results are also typically back then with these tools and even today, sometimes they're communicated out of band. So somebody generates maybe a PDF report and then passes it to developers. I hope that's very rarely the case nowadays, but I'm quite sure that's still available in many organizations around the globe. You also need to, another disadvantage is you typically have to run multiple tools. So maybe you run one for static analysis, one for secrets, one for dependency analysis, etc. And another important disadvantage is also it only detects a subset of vulnerabilities, right? So this is where we will discuss in a moment. But if you look at the effort, of course, the effort is reduced because you can detect more vulnerabilities at a better scale, but you can't detect all vulnerabilities. You still have to use humans or pen testers or other people to help you uncover these. Triaging effort is quite high because people typically don't have the context about the application when you run it. And so this is much harder for people to look at all of these patterns that were flagged and figure out whether they're real issues or not. Same for the fixing, like I mentioned, the fixing advice. I mean, it has gotten better for sure, but in the early days, it was very, very poor. And of course, the app risk is somewhat higher because with all of these vulnerabilities, you don't really know what you're missing. You don't really know what's there. And you kind of have to also prioritize what are the things you can actually fix because there's going to be a lot of results that you have to deal with. If we keep looking at this now, I also want to spend a moment to talk about how these approaches specifically for static analysis have evolved over time. So if you look at the early days again, the tools themselves were pretty much glorified pattern matching. I mean, very much, you have like, you look for certain patterns. If you look, for example, one of the open source tools, Flaw Finder, and they've done great things, no question about it, but it's really just a list of patterns in a regex that is launched against the code base without any understanding of the syntax tree or anything like that. Then it has moved on to actually become better by understanding the abstract syntax tree and not just look at pure text, but understand issues in relation to that. Then the next step was actually improve data flow modeling and taint analysis and these kind of things, so that you were actually able to understand not just is this a bad pattern, but is this a bad pattern across certain flows of the application. And you also have, of course, then later on tools like CodeQL came out and others where you actually start having a full representation of a repository as a graph, and then you ask queries on top of that. And there's also other things like symbolic AI. This is done by some of the security vendors out there. But even if you look at this today, all of these are very much rule-based pattern matching. No matter if it's symbolic AI or CodeQL, if you look at the rules, it's very much saying, hey, look for this pattern. And of course, on top of that, there's other things as well. But it's very important to keep that in mind. So when running tools, you also have to understand that your mileage will vary based on what is the underlying scanning technology that the tool uses, what are the languages that you're scanning, because many of the tools may work really well in one language, but not at all in the other, or very poorly in the other. And often, if you use a certain framework, maybe it doesn't really work because it doesn't understand how this framework actually works. So this is an important thing to keep in mind. Even though tools have gotten much better, even today, they're mostly still pattern matching with a bunch of other things on top of that I'll discuss in a moment. So the next level now, level 3, is continuous scanning. So this is where security tools are starting to be integrated into the workflows, right? So it's no longer just one-off, you run it and you get the results, but you actually run it against every code change that you have, which is great because you essentially get that feedback to the developers much earlier, ideally as early as in the IDE, when developers are actually writing the code. But at the very least, when they create a PR or when they push the changes to the version control system, that's when the tool starts scanning, and that's where they actually can look at all of these issues and surface new vulnerabilities directly to the developers. So this is great, right? Because we all know that when you as a developer are working on a feature, if you're in the zone, if you actually understand all the code and all of these things, you can deal with the issue very quickly. But of course, if you have done this a month ago, you're like, did I even write that code? You forget everything, right? It takes a while to do the context switch. So it's really powerful to actually shift this closer to developer. Again, nothing new. This is hopefully how most of the organizations are doing this these days, but it's actually not something that is still being practiced everywhere. Another, like when we talk about problems here, it's also more management overhead for security and operations teams to a degree, because now you have to actually start managing all of these different tools for different security scans. You have to put them into pipelines. You have to manage them. You have to onboard new repositories, which once it's done, it's great, of course, but it's, of course, more and more work for the humans involved in this kind of activities. And, you don't really cover existing vulnerabilities. You still have to find a way to manage them yourself. But yeah, developers have to do the triaging and the fixing, which can be a problem because, as we'll see in a moment, that is actually quite a lot of work being done by them. And of course, there may be friction with security teams because developers don't like to deal with security issues, and the security team has to come in and they want to just release stuff, and it's actually a problem. Detection effort remains roughly the same. It's automated, but yeah, you're actually amplifying a lot of these things because you're essentially automating tools. And on that level, we also want to quickly talk about how automation integration has changed over time. So still today, a lot of the security tools actually require CI/CDs to work, which means some companies set up complex pipelines, modeling business processes to make sure if this is done, then you run security scan. If that passes, then you can go there, etc. So it's actually very difficult for some. And multiple tools need to be managed, which of course differ based on language and scanning techniques. So it's, like I said, very, very difficult to do. But the best integrations out there actually should take care of that for you. Like, for example, that's what we've done at Guardrails. Like, automatically covering any repo you have should be easy. You just install it once and essentially every new repo is covered. Language is auto-detected, all the different tools are run automatically. So it's important to keep that in mind. This should not be done by humans. And also, of course, PR decoration is super helpful, but it doesn't work for all development flows, right? So if somebody uses trunk-based development, they never see a pull request. They only see commits being fired off to the VCS, and this has to be covered as well. And of course, IDE integrations are also good, but only if developers use them. And there's a lot of different environments out there, and you can't really force them to use it. But when they have it, fantastic. It's the ideal situation. And I think that's also one of the areas where AI is going to help a lot, because it's moving more into the IDE, where it's part of the process where developers write code. So I think this is going to see a big boost in that. But yeah, like I said, when it comes to automation and specifically continuous scanning, there's a quote from Bill Gates that summarizes the best way. The first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. And the second is that automation applied to an inefficient operation will magnify the inefficiency. And I think this is what really happened when we started automating security tools in the pipelines, because suddenly the tools were constantly annoying developers. Hey, look at this and this and this and that. And this really caused a lot of friction and a lot of like the problems that were in between these teams as well. And so there's an interesting actually statistic that GitHub has released middle of last year. They asked like 500 organizations and asked them, what are your development teams actually spending most of the time doing? And by 1% margin, it's actually writing code. The second most time was spent on actually finding and fixing security vulnerabilities. And I mean, it's great that they're spending so much time on security, but does this actually add any business value? And how much time of that is actually spent on triaging false positives and chasing down different things that are actually not an issue? And do you actually think that developers are happy to be spending all of that time finding and fixing security vulnerabilities? Yeah, I don't think so. So this brings us to level 4, which is fixing automation. So this is the level where actually fixes are generated automatically. And so the benefits of this approach are very straightforward. They receive code-specific fixing advice and no longer just, hey, you have a SQL injection, go use a prepared statement without actually any code snippets. And that means developers save a lot of time researching fixes and, of course, writing the code because they can essentially get these fixes proposed. The disadvantages of this approach, especially if you look at where we are today, it currently only works for very simple fixes. It doesn't support all languages, and you can't really iterate over fixes. You typically only take it or leave it, and then you have to do it yourself without getting actually much more benefits from that. And so here's an example of what this actually looks like for a simple autofix from SamGrab. So you can see here, this is the pattern to detect, and this was the pattern to replace it with. So it's really just a match and replace. And so to keep this in perspective here and how this is changing over time and what's happening here, we can see that it used to be very much just a simple rule-based match and replace. We also know, like for SCA and insecure dependencies, it was replacing a version in manifest or the log file, which of course is very helpful. And then what we are seeing already today is like you have this one shot, what I call narrow context, large language model assisted fixing. So essentially a vulnerability is presented, and then the current state of the art essentially looks at maybe the file or maybe a few lines before and after, and then says, oh, is this actually an issue or not? And if so, how can you fix it? And that is a good start, of course. And if this is done already, fixing effort goes down by quite a bit. But this is not the end state. So we will see very, very soon, and I show this as well, one-shot full context LLM fixing, where it's not just the simple context, the narrow context, but the entire context of a vulnerability. We'll also see multi-shot full context LLM fixing, and we will soon see, with or without human in the loop, agentic automatic fixing across the code base. So very important. Now we're going to level 5, triaging automation. So this is going to be very important, right? Because as we've seen, 31% is spent on finding and fixing vulnerabilities. And I think a small part of that is actually the fix. The largest part is actually the triaging and the verifying if this is a false positive or not. So here in this level of automation, we can actually triage and prioritize vulnerabilities automatically. So the pros are, you can reduce false positives, which means less time is wasted both on the security team side and, of course, the development side of things. The other benefit is you can actually facilitate lower false negative rates, because if you can automate triaging, you can look at many more patterns where typically tools would try to find a balance between not showing too much noise and showing things that are relevant. But you can really apply this to essentially look at every single possible vulnerability and start applying, AI to actually start verifying and validating them. And also, of course, prioritize them in the context of your business. Another pro, everybody's happy. If you don't have to triage vulnerabilities and everything is pre-triaged for you, that's great. That's a fantastic experience for everybody. The disadvantages currently is dependent on the vulnerability complexity and type. It's actually very much dependent how well you can do this, similar to what we've seen with the fixing. It's still mostly rule-based today because tools also don't really understand the context of the application. So this is going to come up very quickly as well. Why it's important. And if you look at this, detection effort stays roughly the same, but triaging effort goes down to essentially zero here, if done well. And so if you look at the triaging automation approaches, this has moved from rule-based, where we had like, oh, this file name contains test, so it's a test file, let's not show it, to using, for example, secret verification via provider APIs. You can also see software composition analysis now have more and more of a reachability analysis, meaning does this dependency with a vulnerability, is that vulnerability actually reachable by the imports that this dependency has in the application, and only then it would be actually shown as a vulnerability. We, of course, have taint analysis, understanding whether the input to a vulnerability arrives from something that is actually, user input or not, but also, of course, some logic there, which will show in a moment. And here you actually also have already today one-shot narrow context LLM triaging, where you just look at a few lines around the issue to see if that's a real issue or not, which again already helps a lot. But the real power comes with one-shot full context, multi-shot full context, LLM triaging, and of course with the human in the loop part as well. Yes?
And can I just make a quick comment? By the way, this is brilliant. I do have to jump to the other one. I still have it here. I keep forgetting on the slides, but by the way, I'm going to make you a host so you can just end it at the end, because I got another summit session. I think just one observation, right? I think in the path you're describing, there's a parallel path that has to happen in parallel, which is the ability to understand how the application works and the ability to understand the blast radius of the changes, right? And
Absolutely.
The interesting question here is whether that's going to be driven by security or by normal software development tools. But I think a key part of that level, especially the last levels, you need to have confidence of the impact, right? And you need to almost create unit tests automatically before and after, right? So I feel there's a level there where, developers will be comfortable allowing some of these changes to occur as long as they understand the blast radius. It's almost as long as you can program and define rules on the blast radius of it. But that means that you're going to have to get to a mode where you understand whether you have a blast radius well mapped, or you go, look, I don't fully understand the side effects of this, right? Like this change is self-contained. I can have a high assurance that is self-contained within the application, right? And remember, the application here might be multiple web services deployment, like, it could be quite big. And I think that goes in parallel. But the good news is that as soon as we start doing that, we're going to add a lot of value to developers, because developers need to understand the apps themselves, right?
Absolutely. And I think that's the key point that I'm also going to drive home in the next couple of slides. So you're unfortunately going to miss out on the good stuff live, but
I'll watch the video,
up later.
I'll come back. This is brilliant, man. We need to do more sessions. We definitely need to do a panel in the next one on this. And but this is really, really cool. And I really like how you were explaining the multiple bits and the things. And also let's create those smaller videos, right, to share this bit. Like I'll make you a host, and then you just end it at the end, yeah?
Okay, sounds good. Thanks, Dennis. All right, so let's continue with some examples for this last point here. So these were actually taken from real examples. So I've just tested this today with the leading existing security solutions out there. And this is the code that I'm just going to walk through real quick. What you can see, you have a route defined here. The route checks if the method is a post request. It then takes the username and password from the form, and then essentially calls lib session create with the response, and effectively then returns the response. And this was actually shown as a cross-site scripting vulnerability, even though if you look at the create function here, you can see, oh, it's actually only just base64 encoding a JSON format of the username and puts this in a cookie, sets the cookie as the val_py session here. So clearly not a cross-site scripting vulnerability, but this just shows that the tools don't have an understanding of that. They just understand, oh, user input gets into the response object. That must be a cross-site scripting. User figure it out if that's a real issue or not. And the interesting part as well here is that even though it's a false positive, there's actually a true issue here, because in the way that the logic is used to set a session cookie, which is very bad, because now you can very easily just create a base64 encoded JSON of a random username, which becomes your session key. But how could you actually write the generic rule for that? It's pretty much impossible. So the next example is one that you probably all are very familiar with, which is MD5 hash being used in the code base. And probably most of the vulnerabilities always cropping up insecure hashes or insecure cryptography or other things that may make sense. But in this case, you can see here, it actually takes username and password to create a user, and it just encodes the username and stores this for the gravatar, which is like an MD5 hash of the email. And it would then actually show an icon for that automatically. So that's a completely valid use case. But actually, this was something also that is flagged by the tools because, hey, they just don't know that this is whether it's used in a security context, a security sensitive context or not. And so, yeah, some tools detect this as a false positives, but in that case, they would actually have a matching known bad keyword, for example, password. Only if that's in there, they would flag it. Otherwise, they would maybe not do it. So there's different levels of confidence there. The bottom line is the current tools are not smart at all. They're just very much pattern matches, and they've evolved a lot over the last couple of years, which is great, but they're not going to get us to the last, mile where we need to be to actually address all of these things. Which brings us to the reasoning automation. So this to me is the highest level, because now we're starting to also automate and scale the reasoning and decision making. And this is where essentially, the benefits are that you can apply it, of course, to all the previous levels. You can apply reasoning to triaging, to vulnerability detection, and all of these things, but or fixing, etc. But the key point here is that this actually allows you to detect logic issues in your application if done right, and not just insecure code patterns. So this will detect issues in your authentication, an API route not having any authorization, the authorization not being done, you're using direct object references against a resource that should be protected, so missing authorization. All of these things will be actually unlocked by this level of reasoning being introduced. And this will also consider the context of the repository, the app it's a part of, and of course the business, and also consider any regulatory requirements, which is very important because you can essentially start using natural language to give feedback and instructions to these tools as well. And the main issue here is it's just not yet available. It's not something that you can use today. Which brings me to a demo. So I'm actually quite excited to share this. So what we have here, and please tell me, can you see my GitHub repo here? And maybe quickly say in the chat or something like that. So I'm making sure I can actually show, you can actually see that. Okay, thumbs up, perfect. So then I'm gonna now quickly just push some changes, which should show us here now a pull request that we can pull up. So what I've done here, I've essentially just uploaded 84 files here into a new pull request, which has a bunch of insecure code, a bunch of secure code, and a bunch of other stuff. And what happens here, this is actually the first demo that you see for what we call the AI security engineers in action. And what we can see here is that we are running in the background, of course, tools to detect a lot of different vulnerabilities. Essentially, any possible insecure pattern is being surfaced. But what we also do is essentially for each of these, what we call vulnerability candidates, it would actually go and now look at the entire context in relation to this vulnerability It would look at whether there's any security controls in there. It would look at things like how is the input being modified across the application. Is the input coming from an actual route or something, etc., etc. And after applying all of these things, essentially, what happens? It then reduces all of them into a point where you essentially can only see the real vulnerabilities coming up. And I hope the live demo is working well for us. We're always taking a risk, of course, showing this. But let's see if this completes real quick. Let me just refresh as well, just to be on the safe side. And I'll give it a few more seconds. If, okay, by Dennis and by Damien. So let's give this another second. And okay. So I'm just going to jump back here to this one. So which shows you essentially what is happening here is we can see that the request is finished and that we now have essentially scanned 80 files. Out of these, 33 potential vulnerabilities were detected, out of which only 11 were detected to be real issues. And so this looks maybe very much similar to what you normally see in a pull request. But let's just look at an example in the dashboard to show how this actually looks when we actually identify this vulnerability. So as you can see here, we see the vulnerability that was detected, and we see the source code for it. But you can also see natural language descriptions about what the issue here is and what actually was detected. So you can see SQL query on line 15 is constructed with user-applied input, and this makes it susceptible to SQL injection attacks. There's also two ways that an attacker could reach this vulnerability, and of course, your fixing advice and next steps. You can also see the impact, in this case, excess data, and you can actually see in the analysis details, you can see the different kind of analysis that was being done here for these vulnerabilities. So as you can see here, this is one of the paths, and you can see that you actually have an AI-generated analysis of what happened in the code and whether it was vulnerable or not. So very quickly, I'm just going to show here, data is assigned on line 32, correct. Then this is passed in line 39, as you can see here. Then this actually goes through here. All of this is being done, as you can see in line 11. It calls this function. And here, then it's constructed in the SQL query. So now we also know fully the analysis nodes here, which means the vulnerability in question is a SQL injection, and it explains exactly what it went through and how it determined whether it's exploitable or not. And this is really powerful because you can essentially automatically triage all of these vulnerabilities. And I'm going to show you two more examples. One example here, as you can see, is where it's not exploitable. And we can actually see, you can actually see, oops, the demo gods not with us here. So yeah, you can see here that this was actually not exploitable because even though the code comes from a module, it actually sees that it's initialized with static values before it's being passed to a vulnerability. And the last one I want to show here to give you a better understanding is also the one that we have had in our demo. I had explained actually earlier. So what you can see here is that this vulnerability, which shows the MD5 hash, was actually marked as resolved, not an issue, because the MD5 hash used here is for generating a gravatar and nothing else. And so this is really powerful because essentially you can automatically now triage all of these issues. But that's not all. I want to show one last example here, which essentially we can use for, let's use this SQL injection here. So actually, my apologies. Let me just go to another one here real quick. And I'll take this one. So here we have now one of these vulnerabilities. One of the benefits is also you can now actually have a conversation with this vulnerability. So let me show this. Let's say you now can see this looks like a chat interface. So I can now talk to our security engineer here, which we call Nook here, and ask, can you explain this vulnerability to me? Once we send this question, all the context that exists here is actually available as part of the prompt here. And as you can see, it's able to understand exactly what the context is of the vulnerability and explain to you right away what this issue is. And you can essentially have a chat with it very easily. You can even do things like explain this to me in German. So all of these issues that you have with localization and all of these things, now you can actually have, like you would with a team member, have a conversation about how you can actually understand the issue, what the impact is, how you can deal with it, and you get the feedback in whatever language or dialect or whatever you want, and it works really well. And of course, you can also say things like, you can say things like, hey, can you suggest a fix for the SQL injection? And if you just do this, you can now actually get exact code snippets for how you can actually replace this vulnerability with like that you can just drop in there automatically. And we're also working, of course, on making this completely autonomous. When you have a vulnerability in a pull request, it does it, and you can apply fixes autonomously across the essentially a repository or the applications you have. But the key point is it doesn't stop there. You could even say, for example, if you have another team member, we've added a simple example one that's auditor Barry. Do we need to fix this in order to comply to PCI DSS? And by doing this, you don't just have to have like a security engineer that's an expert in coding, but you can essentially have your compliance, your auditors, you can have anybody in there. And by the way, in the same chat box, you can talk with your team members. So you start having a full conversation about essentially what that means. And I think it's actually Barry with an yeah, sorry. So that's just an example. Now Barry would be a team member, but if you would say Barry, oops, there's multiple Barrys, but let's just see if that actually works in the demo before we go back to the slides. Yeah, so yep, there we go. Barry is responding to us saying, hey, yep, you have to address this vulnerability. Otherwise, you're not compliant to your PCI DSS for the application. So yeah, this is just really to show the power of being able to get the context available to large language models and starting to build the next generation of security applications on top of that. Anyways, so I know we're a little bit over now, so let me just go through the last couple of slides together. So this is really where the title, The Rise of AI Security Engineers, is coming from. Because we're starting to see this shift from, very much cleaning up after the tools that we're using to start and give more and more power to these AI-empowered agents that actually allow us to, improve the work that we're doing. And if you look at these benefits, already today we're using lots of tools, right? We couldn't scan all of these repos, all of this code without tools. But the way that this is done today is just clearly not enough, as we have seen with the problems. So we have to think as AI security engineers as the next generation of tools that are really there to support us to achieve a higher level of, the takeaway more and more of the tasks that we normally do and probably not enjoy. And as you can see already today, we can leverage all of them for triaging and fixing in a really powerful way. But very soon we will actually be able to leverage them for complex reasoning. And actually, we're already working on that as well in the capacity that it allows to understand the repository, understand the different routes, understand the logic, and start reasoning about the application itself, which is really, really powerful. And I'm looking forward to showing this maybe in one of the upcoming sessions. But yeah, in due time, these AI security engineers will actually act autonomously on our behalf, and we are the ones that can steer them, direct them in the directions that we want to explore, so that our time is freed up to focus on the next important issues and the next frontier of security. And this is a good thing. This is how we should really think about this. So yeah, if you look at all of this, essentially, only if we apply all of these vulnerabilities, all of these levels of automation, this is where we actually then get to this full autonomy and full automation, where there's no more detection effort, there's no more triaging effort, there's no more fixing effort, and hopefully no more app risk remaining. And with this, we come to the conclusion. So this is really one of the most pivotal moments in security. And having been in this space for pretty much over 22 years, I really think and agree with what Dennis said, this is the time we can start solving some really cool things. And I firmly believe that security practices will look very, very different 5 years from now. AI securities will start leveling the playing field. And I think us as defenders, for the very first time, will have an advantage in actually as opposed to the attackers. And it's really important to make this progress happen very quickly, because time is of the essence. Because while AI security engineers are being built, at the same time, people are working on AI hackers. So let's make sure that this doesn't happen too quickly, and that we are able to actually not just defend against the current threats, but able to also defend against the future threats, and think of it more like a digital immune system that helps us take care of all of these things, so we can focus on really adding value for businesses and creating the next generation of cool apps and all of that. And with that, thank you very much for your attention and going through this whole deck with me. Please connect with me over on X. My handle is S_Streichsbier. You can also check out guardrails.io and sign up for the waitlist on guardrails.ai. And yeah, now let's open up to see if there's any questions, and go through them. And otherwise, we can close the call. So let me pause here and see if there's any questions from the audience. All right, then I would say thanks again, and we can connect separately and discuss this in more detail.